Yeah, very warm good afternoon to one and all present here. So it's my privilege to introduce the speaker, Dr. M.V. Reddy sir, to you. So Dr. M.V. Reddy sir is working as an Institute of Research in the Institute of Research Center of Excellence in Transportation, Electrification and Energy Storage, Canada. Sir has obtained his PhD degree in the year 2003 with the highest honors in the area of material science and engineering from the University of Bordeaux, France. Sir is currently working as a senior researcher level 3 at the Institute of Research Hydro-Québec Center of Excellence in the Transportation, Electrification and Energy Storage, Canada. Sir is currently ranked #1 highly cited researcher in Hydro-Québec. So from July 2003 to May 2009, Sir has worked at the Department of Material Science and Engineering, Chemistry and Physics, National University of Singapore. Over the past 20 years, he has conducted leading research on materials of energy storage and the evaluation of functional properties of materials and development in situ techniques and material instrumentation and renewable technologies and electric vehicles. STEM, research and education to college and university students. Dr. Reddy has published around 200 papers in various international journals. He has obtained H index of 66 with over 15,900 citations. It's such a huge number. These have recently placed with him with the top 2% highly cited researchers in energy, ranking the 1002 out of 186, means 186,500 researchers in the year 2020. Dr. Reddy is serving as an editorial advisory board member in the Material Research Bulletin and Journal of Energy Storage, as well as several open access journals. Sir has conducted so many workshops related to functional materials and energy storage and conversation and delivered 10 plenary, 22 keynote, 73 invited and 18 contributory talks at various conferences. Sir is a popularly invited speaker in many universities, and he had given popular talks in basic science and engineering, such as physics, chemistry, and engineering, like materials, metallurgy, civil and environmental, chemical, mechanical, and electrical and information engineering at seminars, workshops, and international conferences. So a warm welcome to you, sir. Over to you, sir.
Once again, thanks, Chairman, for your kind introduction. So just I'll put my timer on. Let's see that. So once again, for you, I think it is exactly 2 o'clock. Good afternoon. So here, almost like 4:36 in the morning in Canada. Again, thank you to all. So based on the workshop theme is the research, innovation, growth for under the life skill management area. In fact, this workshop, I can see that various other speakers are talking with a different area of expertise. So although my title looks like this is a way, I don't claim that whatever I'm presenting, most of the people are familiar. In fact, since people are faculty or some people are students or some people are doing research. I think some of the only thing I'm going to tell that briefly, just my personal experience and something like just I'm summarizing the regarding the research, how to publish publications, and then review process, and the end that is called how to write what they call a project proposal. In fact, sometimes any faculty member maybe later want to write a proposal depending on the domain. Just I briefly summarize. In fact, that is also overall. I'm telling that most of the things you are familiar, so that so this is like some general type of the talk I'm going to give. So also I'm not going to give too many details and especially regarding particular research, etc. So I told you that basically I trained in the area of the science, like materials engineering and sometimes science, and then I don't claim that I'm really expert in it. Triple E. Still, I work with engineers based on something. So some slides related to the different type of electrical engineering, mechanical engineering, engineering, or some other part of the domains I'm going to explain. So, and also this conference is also called management. In fact, whatever the research we do, so at the end, like for example, so one industry or anything, I think at the end management or like managerial skills is very important. So, so overall summary that manager also play an important. For example, my own institution presently here is a big institution, finally run by what MBA persons. So they are the people. Finally, they will guide the whole big institutions. So that's why at the end it is nice. I think. So only although you research or doing your bachelor's or your master's, you don't learn too many research. Later, if you take any senior position or like any position in institution, I think your engineers also if you will get an you will go through what research is going on with particular institutions like that way. It's not like really specialized. Still, it is good for you people to the way of partly like humans are learning based on the experience sometimes. So that way, depending on their what they call a job, etc. So I know that presently this is the summary. In fact, I was there in France and then Singapore almost 16 years. So there we in both science and engineering department, etc. So these are presently I based in Canada where the uh, where here this institution is in a hydroelectricity. In addition to this one, especially in addition to this type of good climate, again the extreme climate we can see like low temperature and very covered with ice. You can see during the January, February, March, etc. So these are outline of a presentation. I think today we are going to catch up some part one. I think part two are like that way there. We're going to cover mainly on the outright effective research proposal. So that one I'm going to explain in terms of Indian context. What are the other type of, for example, defining a funding agency, and then briefly I'm going to summarize. So although I don't claim that really, so these ideas will still it will vary depending on the whichever the research you're going doing and depending on the uh, proposal, etc. Who is and also funding agency if it is national and international like that way. So I'm going to mention. So I think these are the things. So followed by final. I think introduction also there I'm going to cover. So what is being a research or some important research area like that way I'm going to, and also so it is very important always research innovation or anybody can do research. For example, starting from high school, junior college, that way we can do. So for example, in terms of always as you know the academic or lab scale they do in a small scale or just like proof of concept, or sometimes if the concept is really good, if they really are what they call as breakthrough research, then we can go for example large scale, or sometimes we make a patent and some patents are approved, and then so depending on the really proposal or whatever the research you're doing is really excellent, and at the end industries will adopt the things, and then so idea here is again industry also they do something like R&D, and once it is confirmed then almost people will depending on the particular projects they can spend like almost years together, like minimum 2 to 3 years to make sure that everything is working properly, etc. So again it depends on which type of the research. Sometimes it is some particular project varies. Example in science and engineering domain sometimes it may take more. For example, IT or information something is a software development, or for example MBA something it may be a little bit faster because of different like area what is the things they're going to do. Uh, so again, I'm mentioning that research. So research, I think is a no boundary. Anybody can do. So starting from high school, junior college, etc. So why I'm mentioning that since suppose we have facilities and something like what they call we need a proper infrastructure, and some environment is very important. That's why anybody want to access the lab, I think we need something like some environment and some mentorship. That way we can do the research. So what I'm mentioning that to see some of the students, although during that high school, like what they call JC, like PUC first year. I think some students are able to spend, although they did with a science project. At the end, as you know that nowadays the students have different what they call as opinions at the end of, although they did this project in second year or sometimes, so depending on the market, sometimes some students are able to go to engineering again. They're going to engineering, triple E, mechanical engineering, and what they call engineering science program or materials engineering. And some students are able to go to join in economics or business. So make sure that they, and some people are going to law. So that's why, like nowadays, the kids, anybody, the slightly they change depending on the interest, and then that's why. So so what I'm telling, what is the way we are trying during this particular what they call class 11? I think there, I think some few examples we demonstrated. I think almost 15 years I've been trained almost many more than 200 people's students. Uh, like every year with the different batches, for example, 2 to 3 years. It's almost like 1 year part-time program. So that way, so advantage of Singapore, you may see that so there's a small box like almost 30 to 40 kilometer radius. I think anybody can access, well connected access, and then it called a smart city, so that everything is so since the good infrastructure in terms of transportation, everything like MRT, everything they're able to access easily. As a consequence, some students are able to what they call attend from the different part of the Singapore, so it is easier for them. So that within 45 to 1 hour they can reach the laboratory. So that is a little bit advantage. That's why we, due to this, so many students are able to do research. These are the small what they call achievement. You can see people are interested. Maybe you can go through some particular website. Still, almost all the links are available. So for example, different type of program. So why I'm mentioning that all the things, research, everything depending on facility, depending on this one. So we can do the research, and so that way all this, like for example, research publication or any review, all by, I think we learn by experience. That's why I'm telling. So for that case, we want to be original research. For that case, we have to do some experiment. It may take some time, and that is also depending on the what facilities are available and infrastructure, etc. So I'm telling these are the small outreach programs, and they can, please, if you want, you can see, and some publications. These are a few examples regarding the publications with depending on this science research program or science mentorship or science in action, etc. So what I'm telling that these are few example again. So these I'm talking about some material science later. I'm telling that although so we have similar type of programs in some engineering category also sometimes. So 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 again it will vary depending on the which department, etc. So these are the small. Some students are able to present a presentation like international national conferences or their own specialized conferences. For example, science and engineering fair and science research program or science, yeah, science research congress, etc. So what I'm doing, this is the way we are as a like a researcher or any academic teacher or professor. Always we just our responsibility just to motivate the including bachelor's or master's students, just whatever the way. So at least we give some guidance, and later I think do so for them you have to give some exposure. Later they learn the what is meaning of science, engineering area, etc. So again, some students are able to present it in the various national conferences. For example, Intel International Science and Engineering Fair. So this conference is going to held in the uh, USA, and for example in Poland, Europe, and Japan, etc. So I'm telling this is a way. So as a any faculty or any PhD researcher, just to go to give presentation at the national conferences. So it is like depending on their own and the age with this platform to present. Since this is the way the workshop is going to be, is a medium just especially for faculty and students just to learn the what are advances, and depending on the expertise, or just we are presenting and then we are learning. This is the way we are learning, especially in terms of international workshop, internet. So that way it's good for just what they call enlighten our knowledge, etc. So again, also we have done some small public outreach with different with the small levels of the uh, different with the different groups. So these are small groups within Singapore. So already I mentioned that bottom row, many students from India. I think they are also coming from different university. They visited our lab and then they did the PhD, and some bottom from people from Iran and some people from USA and etc. So what I'm mentioning that although so as a researcher or academic, I think so this academic, like any university, the way we have a lot of freedom, and at least we can that our job is just to motivate or train the many students. I think they will utilize the facilities, and they can go to the to research in the area with the different domains or whatever the research they want to do. So these are the small collaboration within Singapore as well as some different part of the world, and also few places from India also. So these are although I claim that this is my research. So for example, you know that all people are using their mobile phones. There is a one called lithium batteries are future. We are going to run with electric vehicles. I think that's why. So these also so this area is an interdisciplinary area of the science and engineering. For example, we have to work with electrical engineer or mechanical engineering. Again, if we want to talk about the system development or chemical engineering, etc. So anyway, these are the so I don't want to discuss too many details. So as a depending on the as a, any engineers or anything depending on the expertise, we can focus with the based on their expertise, we can do different things. So luckily, I have had nice opportunities. Although I worked with a lot of people from including telecommunication engineers and triple E engineers and civil engineering, also mechanical engineering. So that's why while doing the research, it has no boundary. For example, I understand during bachelor's or masters, they have some particular things due to time limitation. Always we are focusing on a particular area. Still, you see in future, like education system, I think, or like especially during engineering or university, sometimes depending on the university, or they have different type of the program, so they can do whichever the area of interest. For example, what they call energy engineering, and this the multidisciplinary course are going to also what they call as main and selective, etc. courses are going to taken for the students. So this is my outline of my presentation. So what I'm going to introduce the things, and what is the meaning of scientific method, and how to write a research proposal and reviews, and something like how the review process, etc. And at the end, I think the last presentation with how to write a research proposal. I think this one, it may be mainly applies to the faculties or young things. Okay, still, I think sometimes this one is also applies. Some students are attend at the end of finish PhD or later they are applying for the, for example, overseas research fellowships from their some particular what they call a grant agency in Europe. I think they will ask you to write also something like what is the your research you want to do, some proposal like that. Just they'll submit it and they have to wait for some time to get the answer. And then if you're lucky, depending on competition, your proposal is really good and you will get something like based on the what one will get some funds. So later you can do 1 or 2 years or 3 years depending on the funding, and we can go there do the research. So again, I think also sometimes these little bit tricky also. I'm telling you, depending on the research proposal varies depending on the funding agency or what really doing, or some cases is more specialized. I think they will focus on particular things like that way. It depends on what type of the if it is academic agency or industrial agency. Sometimes in Europe or some other places, some particular industry there is more confidentiality. So for particular case, you have to be a little bit different way of working. Although sometimes they may not be, you may not be eligible. Still, some patented issue, what they call confidentiality, etc. So again, it will vary depending on the project to project and which project you are working, etc. So again, I'm talking about introducing that evolution of the research. I think what they call as the empirical research has started by empirical. It means based on the experience. We know that especially for example, agriculture, machinery, carpentry, or some other type that are all based on the experience. So again, another two categories are, for example, theoretical only sometimes the theoreticians, the only theory, okay, they do some theoretical models, and so then they can do the research. So they don't worry about if it is practically working or not. That is another category. And some people like us, so or for example, they're designing the model saying, oh, this particular model is really good for fitting for electrical circuits like that way. So they sometimes practically they will not still there's a one type of category, and they do just theory it may be useful to. And another some people they think working on the experimentals, sometimes they always experimental really work or not, and then that experiment also depends on more fundamental or applied, etc. So we call it pragmatic type of research. And another one is a societal based research. Again, it contains both theory, experimental, and at the end is application. And finally, and it includes your business. So whatever the do you do at the end, whatever the at the end should be applied, and then it is applied to industry. And then again, the industry they have to sell the project or product, and then they have to make a money. So again, so these are one like what they call a human history of the, for example, materials based on prosperity. So all things originated, I think, by Stone Age and Copper Age. Again, these are all the Iron Age. All people are familiar. Rubber Age. So and Silicon Age. I think, what for example, people are IEEE engineers. I think this age made them to revolutionize. For example, discovery of vacuum tube and phones, and for example, semiconductor industry or future. For example, your mobile phones, etc. So again, this area I can tell you the revolutionized. Again, that made them to talk with me in front of you. That's for example, all the systems. So that's why because of the silicon that with the computer, all this one. So that's why anyway, these were all initially a lot of difficulties. For example, so they're all different nowadays. For example, presently we are facing that something like bandwidth problems depending on remote villages. Still, I think there are a lot of interesting things is going on with the 5G, 6G technology materials, and yeah, how to improve due to COVID situation, etc. So again, this is a way we are adopting depending on the what they call as the situation. So another one is for example, composite age in 1980 and functional material age is around 2000 and molecular age. Now always we call as the future intelligent materials are low carbon age material in the sense that, for example, anyway, intelligent means the word is very vast. So if you talk about IEEE or mechanical engineering or chemical engineering or so, for example, some intelligent material we can, for example, in case of computer. So there are all things, although so the way of telling the again energy, environment, and health, and what are sensor, etc. technology. So just for example, one example I'll tell how the research page, for example, so making sand or making carpentry or agriculture, really we don't need a research. So that is all based on the experience. I think see like for example, ancient converted sand into glasses. So as you know that with so also it is like art, so that's why they can learn and then by all by experience, and then so they can do very beautiful depending on the glasses, depending color that they can do white or glasses. So these are like again it thing is art, it is same thing like in machinery, carpentry, etc. So another one is now recent trends. Always people are talking about industry 4.0, education 4.0, and always it is very important is digital and so societal transformations, nonlinear model, and basic and applied and commercialization. Again, this is very important. Once you do basic science, again it has to be applied and commercialization. And once it's commercialized something, then it needs to again industry. There are all this then. So at the end, the management business so it's very important. Whatever the industry, only they expect is that so whatever that we do, we can get anyone any return or like it's like a business model anything. So this is the way it will work. The system I think it applies to for all the areas of the research. So now if you talk about in terms of especially the areas, I think recently not only energy, environment, or sometimes sensor, etc. to the technology is very hot area. Suppose for example, if you talk about the autonomous vehicles, I think there is called a lidar type of sensors or radar type of sensors. I think that will be very useful for the
Hello, sir.
Sir, good afternoon, sir. Sir, your voice is not audible. You're muted. Can you please unmute? Ready, sir?
Your voice is not audible, sir.
So now it is clear.
Yes, sir.
Okay, I'm very sorry for because thanks for reminding. So usually it has happened maybe software, I'm not sure. Okay, so now
Okay.
now shall I continue or how long it has happened? I don't know.
2-3 minutes, sir.
Okay, I'm very sorry. Maybe up to maybe somewhere here.
No, sir. Same slide, sir. Same slide.
Yes, sir.
Okay, I'm very sorry for. Okay, at least maybe some problem with the system. Automatically it has done. So maybe unmute all probably you would have done this. So it has happened. Okay. So anyway, these are all the summary. Maybe you would have done. I think the slides we have seen. Okay, so these are things already I covered, and then this is areas. Okay, so
Yes, sir.
okay. So anyway, thank you very much. If anything, just please remind us. I think this is very useful. Okay. So again, so if you talk about the materials, although I'm talking about in terms of the one particular area, so for example, in terms of materials, again, so if it occurs, for example, civil engineering, again, they call as a construction materials. So there you can see a lot of changes happen. It depends on our buildings also. It will vary depending on the where in countries like India, way of construction is slightly different, especially here. So we need especially smart materials or building. I think always we need something like insulation material because of the again the temperature everything is to change. Or sometimes people are always I saw some few reports what they call phase change materials, especially already some demonstration has been done. For example, in the wall they put some phase change materials. I think it will sense the temperature depending on the with the type of season accordingly. It will monitor the temperature etc. And also the electronic material, for example, silicon age, what they call a silicon germanium, I think they're very important for especially for solid state electronics and EEE engineers. Although you will not bothered about especially what is in importance at the end. So as a materials engineer, always they worry about something in order to get a good device or a Cosmos device or sensor. I think these particular things of materials are interesting or sometimes called as the nitrides or silicon. I think sometimes hard material needs silicon nitride, or depending on which type of things is very important. And sometimes energetic materials, engineering sometimes with mechanical engineering, always they're calling about the super alloys. So I think where especially lightweight, your mobile phones, I think although casing, so we need something like lightweight super alloy based materials. And again, and also sometimes we talk about the based on the physical properties. So these are the different type. Although so don't feel like once you do the research, these are all the more depth. They're all things we learn by reading the things. Although your background is slightly different, that is the way during that 4 to 5 years as a researcher we are going to understand the concept. Although so your subject area is different depending on sometimes, for example, EEE engineer, they're doing something like integration of the electric vehicles or battery to into the autonomous vehicles. Although so they're not familiar during that your bachelor's, always they're interested about sense how to make integration like sensing all this one they do. Again, if you go for more research or go to the industry, I think always all people have to talk together and then so that way you will learn by experience also some expertise and then at least you and again you by reading by the literature or some particular reviews that may be useful for you to get the improve the knowledge and what is going on with respect to your own domain etc. Anyway, these are the one few example of the impact of the iron steel for the transportation technology or if you talk about the aluminum especially for aircraft and then our composite materials for the different type of applications. Again, I'm telling that always people are talking about the smart city or smart sensor. These are the few example I think I've collected from Singapore. So these are the something like again the smart lighting or all this one again LED or smart technology or so are the smart mountain and that all the things I think all people like especially information science is very useful to make. There all the things are already known. So another area is, for example, is the smart windows. Suppose you can use for a smart glass or lasers and etc. These are all the importance of this one. So I think I'm talking about these are the some important areas, although I don't claim that all the things. So usually, as you can see clearly, smart materials, especially with smart building, thermal insulation, etc. And then energy saving lights, especially robots, shuttles and for the motors, and smart glass and transparent and magnetic and green concrete, especially if we talk about the engineering side, and advanced flexible organic materials for especially plastic membranes and bioplastic and advanced polymer is useful. Again, another area is the resistive switching memory applications. If you talk about the thin films, I think these are all the things, and especially sensors. And I think nowadays, especially if you are talking about the autonomous vehicle or your car, something like semi-automated system, I think there, if you want to be everything is to sense, I think the sense what the lidar based material. I think the sensor based materials, sensors are very expensive. So that's why in order to reduce the cost, I think we have to look for something like what they low cost materials for the lidar sensor technology. Again, something like 2D, 3D materials for the CNT and smart city applications. And other areas is called 5G and 6G terahertz electronics, if you remember. And smart materials for the smart grid, electric vehicles, and autonomous application. Again, EV chargers. So again, this is the very importance of the electrical engineer. Always we work in, especially if you talk about the in terms of grid storage or building or including your particular example vehicles in the your for example your car. As you know that nowadays with high-end car everything is so like olden times. So you can see now everything with a information system or computers science, they can check all the things with the software. They will see what is going happening with their car, etc. So that's why now technology has been done. So after doing all this one, although at the end I think business is very important, although we are the people leading the things, and then that's why I'm telling that always it is both science and engineering and etc. That's why sometimes after doing engineering or master, sometimes people they do something MBA. So that's why you already know the knowledge of the engineering or science, and then you again go to the how to make a management skills, etc. So that all this one we learn by experience later, depending on the time, etc. So again, so what I'm going to mention is that so 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 now, for example, so now we will come into the research. So whenever the research or anything in terms of the project, what are the things you want to do? So best way is that to read the literature, including reviews or patents, etc. And check the recent trends of research. For example, we know that all, for example, electrical engineer, they have some particular trend, all depending on the expertise, and also depending what is going on in the, for example, what are the available facilities. That is very important. And you know that if you're doing with BTech or anything, your own engineering, sometimes I know that very, although you have a lot of what they call as motivation to do research, sometimes due to time limitations or facility are not available facilities, accordingly you have to focus it. So that is your research. That is the way I'm telling. So I know we can do sometimes if your infrastructure is good or good collaboration or industry, or those are all things you can do collaboration. Again, that one is a little bit chances are less. Why I'm telling that sometimes nowadays I don't know how the industry, like sometimes industry they think that something like confidentiality, or so you're fresh students within 6 months you will finish the project. Sometimes industry people they have to spend a lot of time with you training. Sometimes they may not be. Still my suggestion is that as a researcher, always you to motivate the young researcher. Just a matter of few 1 or 2 days, I think they'll pick up. So that's the way research will grow. That's the way I think at least it's nice for the senior people who have to train the juniors. That is the way case to continue. So that is including that not only academic research as well as industry, etc. So check the recent trend of research and then what available facility and for example energy, water, healthcare, etc. Sensor technology or digital technology or business. Anyway, I'm not really expert in what is business, what is especially particular areas. So I also can tell that like in business management, etc. So if you talk about advanced materials, again we can use it for the photonics, spintronics, and aerospace applications, and sometimes called as sensors. Sensor is a very good area. So I think people can do. It will apply to the all type of things and the environmental photocatalysis, solar, and healthcare, and there are all the. So I'm telling these are the some particular types of material. Again, it depends on the topic. For example, information science. So again, the development of the software for different type of for example, environmental sensing or smart city development. How to like for example. Some what they call traffic sensing or some software. So these are way, for example, all GPS, everything, all things that is came from the information science, etc. So again, I am talking about the anyway we can see energy, environmental, technology, interdisciplinary area of science. Sometimes you have to. So if you go for more basics, sometimes we need some physicist, chemist, or sometimes material like engineering. Also again, it is a materials engineering, production, chemical, civil. I'll tell you they're all things, and electronic and computer science and automobile, and at the end I think is management is. I already previously mentioned that management science is very important. So about like management, so that they are the people who lead the things. So that is the what they call as whatever the research, innovation, everything you do. Sometimes the industry, but also finally you have to manage by using the. You need a good manager, so that then only. So anything it be more what they call a cycle should be completed. So, so another important area is called the autonomous electric vehicles. Again, so for example, you see this one again, autonomous electric vehicles uses the self-driving vehicles. It will use artificial intelligence and light detection lidar technology and radar type of technology. So again, the major benefit of autonomous vehicle is the lowering of fuel consumption, development of the smart cities, and also we can reduce the CO2 emissions and the traffic consumption. These are the uh, uh, expected revenue, almost like a 7 trillion revenue expected. And again, people are telling that we can reduce the 90% vehicle I think this way is good. Only again, the major challenge is use of this particular driverless vehicle. Then people are talking about the cost, and then it's almost 3 to 4 times higher than the present model. So sometimes the cost is also major. So that's why I will at the end the people cost makes them to use anything still. So this is a way of the always researchers are concentrating and other thing. So this is a typical diagram. For example, you can see the smart autonomous vehicles. You can see, for example, lidar center, video, and there is a small thing like central processing computer. Again, so here I am mentioning that we need the importance of the computer engineers. So just to make sure that everything is going to work, and then GPS, etc. And again, I think you may see somewhere it will be engine, or sometimes backside is the battery. So again, in summary, I think there is a lot of both engineers or scientists, all people are working in a group. If you want to do this one, I think this way it is research or anything, whatever we do. So if you go for industry or anything, at the end, all people have to work in a group. Then only we can solve the what are the particular area. For example, not only this one, same thing. People are talking about a grid again. So there, I think we need the importance of electrical engineers and electronic engineering, or some people from the computer science, and then etc. etc. So I think these are the small opportunities. If I'm talking about the electric vehicles, etc., there's different type of the companies are invested, etc. So now I think 1 or 2 slides. I think why am I mentioning that? I think this is very important area. Also, in my own specialization, still I think people are using the batteries, for example, mobile phones, or future you're running with laptops and electric vehicles, etc. For example, this type of thing. I'll briefly summarize what are coming. There's only one slide with a little bit detail, and then afterwards I'm discussing that what are the contents we propose. So, and these are little bit cylindrical cells. If we also using for in case of laptop, etc. Again, the materials are same, depending on, for example, grid there we are looking for the low cost, etc. So for example, if you talk about your electric vehicles, again the same type of batteries are nearly, depending how much energy rated, and nearly, if I remember, almost like 2000 cells like that way. So I'll put it in this particular pack. Again, I think we need something like, although it is simple pack, you need at the end, once you make a real cells, and we need a sensor, detect the temperature, or what they call a battery management and energy management, etc. is needed. So this is the way. So again, so we need something like, say, in order to make a sensor, all this one, or integrate sensor into the system, we need the electrical engineering, and also in addition to the like scientist or mechanical, etc. So these are the research. If you talk about this electric vehicles, always, so these are, we always, people are looking for the high energy density and power density in the material level. For that one only, people like materials engineers do that one, look for the novel materials to make sure that it be high energy. This is very important. Key role is that always people want to be high energy intensity. The basic level has to be improved, something new material. That is the way it has to come. That's one only we can do the like universities and then institutions, and then other people can do. So again, I think this is the first part. Once you do this one, again, I think it comes under a lot of engineering and mechanical. So unless, if I don't increase this particular areas, so we cannot what they call long lasting. Those are all things we can improve. So anyway, still, so for example, if you want to be fast charging, I think we need something like. So although I have some good materials, anything, so I have to talk with our charger, how to fast charger, who can develop, only electrical engineers. So they have the talent. I think they can develop depending on our requirement, etc. They can do. So again, sometimes you want to be material development, you talk with some nanotechnologists, etc., etc., etc. So again, if you talk about these smart vehicles, you can adapt the climate conditions, sometimes depending on temperature is to see long cycle life, and then for example, lungs, it has to, so it is very important, reliability, whatever the promise, the kilometer it has to come, and then coulombic efficiency is very important, and impedance of the cell is also very important, is to get low resistance, etc. After doing all this one, so resistance of the cell is nothing but once you doing, I think people are telling that, oh, my batteries is going to be die. So that all things you can shade by in something like electrochemical impedance spectroscopy. So these are like, impedance analyzer. Again, as you can see clearly, so they call it AC impedance. So there we, so this also instrument is in developed by electrical or electronic engineering. So that's why this is the importance of the engineering. After doing all this one, so we have to look for the more safety, low cost, and toxicity. And the end, here also I'm telling you about the business will come. So whatever they do, this one seems to cost. If cost is lower, I think we can make a lot of profit. That's why they make a business manager model like, okay, whatever the research you do, so what is the cost? If it is too much expensive, they don't worry, So that's why they don't care also, not care. So it is the way the business model will work. So I think they will see the profit. And so again, after doing all, after the, especially in terms of material wise or anything, you do the sustainability in recycling. We don't want to any materials you use you to recycle. That is the model people are adopting. So I think this is the one small quick slide how the battery components are any typical your mobile phones, etc. So it contains, for example, so there is a current collector and there is a cathode. For example, it contains some metal oxides somewhere here. So again, another side is the graphite, and then copper as a current collector, and there is a separator. So remember, so here, so it will vary depending on which type of the sources. For example, people are talking about sodium batteries. You can use sodium containing compounds and potassium and lithium, etc. Again, we know that this type of natural resources vary depending on, not all the places cannot get, and only it applies to the particular area. That's why they call mining industry. So that all the things now it is like it will vary depending on which country they have, and that's why sometimes they call it exploitation. Depending, all some people cannot do the how to extract. That's why some collaboration or some international people do the things and they can extract. So that all things is going to happen. So another one is the sometimes called oxidation, is analytic scan, positive current, state of charge. Discharge is the reduction, cathodic scan, and negative current. Electrolyte, we use 1 molar LiPF6 CDMC, ionic liquid and polymer and solid electrolyte. Current collectors, we use the copper, foil as anode, and etc. Again, these are the things. For example, I'm talking about system level. You want all this to integrate. We need some stainless steel container, etc. and binder, etc. So this is a typical lithium battery cycling manufacturing process. First step is the mining and processing. Again, for example, if lithium is there or sodium, any metals you have to extract and you have to use it. Usually you have to do metallurgy approaches, pyrometallurgy or extraction metallurgy will comes into the picture. Again, the importance of metallurgist, and so I'm talking about these type of important elements are needed. And the graphite is anode, negative side. Again, this one we can do, the graphite naturally occurring mines. Again, it will vary here also. We have, especially here, good mines. So that's why. And electrochemical production. So, and again, the manufacturing side and end use, etc. For example, if you talk about the electric vehicles, I think there we use a motor, permanent magnetic uses a rarer type of material. Again, we have to look for this type of, again, the cost is also, it will vary depending on who people are, who are the people having more rare, so they have a little bit easier to extract the materials. For them, it's costly. Sometimes it's monopolized. So another one is the end use applications. For example, we can use it for smart grid or electric vehicles, or anyway, the same material we can use it for your laptop or your iPhones, etc. So again, you remember if you compare your iPhones or your laptop, there the battery is a small pack, the material is too small. If you go for EV, I think there we need more materials. Again, they need like more resources, etc. Finally, I think we have to look for the what they call as a recycling the trend. Okay, it is a typical principle. I'm talking about the how the typical batteries. It means once you charge this one, lithium move from the cathode to anode. It's like shuttling of the lithium, for example, where the electron will pass to the external circuit. So what will happens? So for example, lithium cobalt oxide, the color the oxidation will occur, means remove the lithium from the structure. Again, go back to the original state. So it is very important. So what are the things you do? So we have to understand this concept. Understand this concept. These are the, and we want to get high energy density. That's why we need something knowledge in this one. So once you chart this one, you can see, for example, remove the lithium, you can get some oxidation and reduction, current versus voltage potentials. So remember, always you have to get a positive and negative current. So typically, if I want to plot the voltage versus capacity, you may get something like this particular example, 3.5, 4.0 or 4.2. So again, something like the negative electrode, you can get something like 0.25. So the voltage of the cell is nothing but difference between the, for example, top, the cathode minus anode. So this is called as the voltage of the cell. If you're talking about the energy density, this what is the voltage of the cell multiplied by what is the capacity here. So now practically somewhere around 200 or maximum we can go based on this one. Now if you want to get high energy density in terms of material or fundamental level, always our job is to extend this particular potential. For example, now so if you get in any what they call smart material or anything, it will go up to 500 milliamp per gram. Then it is another breakthrough. So that's why you don't need too many big packs to put it in. So that's why again cost we can reduce further. And life, for example, the same battery you can use it for your laptops or mobile phones instead of getting it. May battery may last for 10 hours, 20 hours, depending on the which type of the chemistry or which type of the battery, particular high energy battery you're using, like that way. So I think these are just like I'm going to skip, since it's my specialization. I'm just going to stop. This is something like I think this knowledge I'm putting because sometimes people want to work with the electric vehicles or a mechanical engineering or sometimes different type or your own batteries you're using Sometimes you may see like in depending on battery manufacturing, sometimes you may see the bulging of the batteries, something like, or sometimes flammability and explosion. There is a different things are there. Since I don't have much time to discuss, so later if people are interested, I'm going to touch up in last next presentation if time permits. Okay, that's why sometimes what I'm telling that yeah, as a electrical engineering point of view, people what are the mention the safety limit to load cycle. I know you sometimes you may get some high capacity, may go to slightly higher voltage. So my suggestion is that restrict the voltage as a what is the manufacturer suggested. So if you go to higher, although you may get slightly higher capacity, sometimes you may see some explosions, some other issues. That's why safety is also very important. So now we go for a little bit more, a little bit something like same story, whatever I'm talking. Now we can go for a little bit more on scientific methods. Usually, so what aim or what is it you are going to try to figure out at a particular project or particular research problems and solve. This is the aim of the things. It is applies to all, including any type of domains. And hypothesis like nothing but educated guess or like what is the research. Either you can do two ways to write depending what type of experience, all based on the experience or literature, or based on the, for example, mentors advice, etc. From example, your own professors are going to give some advice. So that is the way. If you can't guess an answer and what are the, for example, so once you mix the salt with less water, how the density is going to vary or viscosity is going to vary. For example, once you mix the sugar with like water or salt with water, how the viscosity is going to vary and what are the things. I know that if you increase the concentration, etc. So like that way, same thing depending on which type of domains. And if we can get an answer, we know that density will increases depending on the material or depending on the oil, etc. Those are all the simple way I'm talking about your own example. So life and materials, a list of all materials used in the experiment, everything. Again, it applies to, for example, some people are working with the information science, or some people are IT, IEEE. So from there, I think they may use some different way. I think what type of the software they accordingly can mention quality and size, etc. The material is very important. So what type of procedure? Either you can do variables, again the experimental variable, again it will vary depending on the, for example, mechanical engineering, again they can, if you engine, I think they can vary, those are all things what are being tested and what is the impact and factor change during the experiment. And dependent variable is what being to be measured and what is affected by the charge by experimental variable. And in the control variable, what remains unchanged, I think is very important during experiment. So this is a way, for example, if you do any research, always sometimes new materials, always they think some control sample, So if you do different type of batches, make sure that my control batch is coming like this way. So later it applies to all type of the category, including, for example, pharmaceutical or other type of industry, etc. Again, it applies to, for example, solar cells. So I think they have some particular efficiency with the controls, some standard sample like that way you can do. So another thing, result, how to you have to put it. For example, if you write a proposal or like a project, you have to. I think the way nice way is, for example, your own dissertation or summary of project. I think tables and graphs are really legends are visible. I think that is the way we can tell. And then, for example, you have to see the data in a properly plot written. For example, depending on the what type of the how you are going to something like what they call data errors, all this one or for example quantitative and qualitative descriptions. In conclusions, usually repeat the aim, what it was there, and repeat the hypothesis and accept and answer all the correct and incorrect, and answer the aim and support your answer, evaluate the validity of the hypothesis, results show and what is going to happening or sometimes correct, incorrect. I know this is sometimes a little bit tricky. Sometimes you may tell that, okay, although this is my based on my expertise, available facility and based on this, still you can mention also you can do incomplete saying that still further studies under progress or further studies done by doing some XXX technique like that way you can mention, okay. And again, price or external validity of the methods and prove the data and improvement and extension of the method. For example, future you can do something like that is the way for any researcher or PhD researcher at the end you can tell that improvements or extension of the studies. For example, later you're going to other colleague you are going to do, or so that is the way of the research it has to do, go. The same thing applies to almost all the domains. And again, for example, future any experimental, for example, yield improvement as a chemical engineer, always they want safety, all this one can improved by future. I know that any research, anything within 3 years, 5 years is difficult to do, because or within 6 months or 2 months, we are not able to do 100% what is it still. So it is a way of learning, and within the limited time, I think that way we are going to learn in a way. So anyway, at the end, we are learning based on all the procedures. So now we go for a little bit different way. Once you get some report or ready, and then sometimes at the end, people like researchers are, for example, I'm bit experienced. No, I wanted to go to research. I think sometimes if you go to international university, top university, I think they will see. I know that your engineering grades are really good. Sometimes if you have some publications or something like reviews or etc., it may be given additional credit. They think that okay, this fellow, what are the research has done, he is published in some journals. I don't tell the journal also. I'll tell you later what is the story, how it will work. So in summary, I'm telling this is a way, since it's a competitive world, this is a way to screen. Example, same thing applies to our university or NRF or ranking, or so there are also for that case also. I think research is also in addition to teaching, what they call as these are the academic research. We have to do teaching, research, and outreach. So these are all the points you will take into consideration. Again, if you do research, I think that will be good. Some publications, either national or international conferences, I think that is, and also proceeding, or some top journals. I think that will make them to little bit easier. That way you can tell them, oh, okay, so this publication I have to prove, oh, this fellow is good. So that way we can observe. Also sometimes, for example, any faculty, some people are specializing, oh, this persons are really expert in particular area. So as an international research, okay, this is good. We can collaborate. That's the way it will work. So that's why research or anything has no boundary. Some novel idea, novel concept, anybody can contact you nowadays is the internet. So it's easier for us to do all type of the things. That is very important. So that's why I'm telling that. So this is the way our system is going to work in a, like if it's good ideas, anybody can contact now. So you no need to go. For example, me, I'm presenting from somewhere in Canada. So that's why technology is like very similarly. So I think results we can discuss. I think some new ideas. I think people can you can exchange the things. That is not a problem. So example, if you have to write a, it is very important. These are small tips. I think all people are familiar. I'm not telling that everything whatever I'm telling that is a new. So it just is like this is the way it will work. So usually that we need a acceptable title. So in the sense that depending on domain, you have to appropriate title, whatever the research you can do based on this one. You can learn that is not by experience, and you are all familiar this one. And abstract, introduction, and what is going have, especially introduction is also very depending on the type of domain to domain, and always from there you have to discuss what is going on recent, and then you have to, depending on which journal you're submitting, accordingly you have to cite the references, etc. And I'm going to mention the literature review is also very important, and results and discussion, conclusions, and afterwards proofread means how much time to review. And once your proof is ready, and your job is that again you can submit with online, upload it, and then then it will go to the editorial process, again the review process, etc. So I'm going to mention today maybe up to that review process I'm finishing later. So I'm going to maybe next presentation will touch up on the review process. So again, and also writing manuscript, again the experimental design. As people are talking about the impact factor general, that one we'll discuss in the later slide. Uh, Again, high impact publications will improve the citations. Again, novelty of the research work and new and innovative methodology. It depends on what is the really new, and these are all things. Again, design and development. They, for example, in terms of new material, composite sensor or smart material, etc. Or again, mechanical engineering, how to improve your engine efficiency, like that way. They're all things. It is okay. And the computation details, what are the models you're using, again you to do. Or for example, if you're engineering things, you see which type of software used, and that way it is very useful. And characterization of material, which type of what type of techniques you are going to use, and analysis of the material, etc. And we're doing all this one, sometimes management. So for example, on nowadays, I think people are talking about the in project proposal submission, you have to see the safety and risk assessment, So they're all the things to take into consideration. So what type of research we can do? The research based articles, reviews, letter, and sometimes in comments and replies, and sometimes you see discussion, errata, and conference proceeding. These are all the different type of categories. I think they're all things you learn by experience. Usually, research article letters are like ethical communication. It will be small, it's not a full length articles. So preparing a manuscript, what is always people are talking about novelty, or sometimes it depends on the various. For example, in particular areas, they will see some improvement in. So your job is something like improving the thing, and what is the message? Put in the context in the appropriate references, and you have read it by others. Is very important. Whatever things anybody can read your once you publish something, it allows whatever people have to read, and it is something like so some particular things you have to don't make it too long. It may be shorter, and then sometimes and also invest time in writing also. Sometimes always there's any fresh people. You try to do 2 to 3 drafts, 4 drafts like that. Don't worry about first draft, second draft. I know that is a way of learning. So sometimes depending on the example, 15 times corrections done by all author with the Professor George Side groups. So this is the one example. So he's one of the well-known professor from Harvard University. So that's why sometimes it depends on which it depends. That's why always people are telling that whatever the research you do, don't wait for the till end you to write a paper. So start writing, you get some data parallelly, start writing, you make a introduction, experimental things and data. So it's also incomplete data also is fine, still you start writing. So that's why parallelly you can do both the jobs. I think that will save your time. That is my personal opinion. So again you have to follow the grammar, punctuation, spelling, etc. Again, sometimes I know it will vary depending on which type style of the journal and then etc. Logical structure, clarity of the content, for example, misuse of the and then these are the small errors. I think that one you can learn by experience, just by corrections like etc. You can do 2 to 3 times proofreading, etc. Use of short sentences and read the. Anyway, nowadays sometimes I know that some colleagues or people can read. People don't know the area. They let them go through. They'll suggest you. And also other options sometimes recently, I think some language services also will do, especially people like Indians. I think that language is not a really a problem. I think we once you have data, I think we can write the papers. So that's not a really a problem. So do you know again? So people are talking almost like 5 million or 5 million workers in research enterprise. Almost like almost one new paper published in now it is the olden time is almost like 10 to 30 seconds. So it's almost like around this much number of the papers we publish. It is more than this one, or more than 1 million citations per month. So again, at the end, it also will make a business. So starting from publishers, and then again, I think at the end, people have to make a money. So again, the business model also will come. So overall, it is looks like again at the end is business. So anyway, I'm not telling like all 100%. Still, it is this is the way. Whatever the way you do, each area is like this way. And again, so for example, so depending on, for example, IEEE try to select the scope of the journal. That is very important. Check whether the subject matter of the paper is been within the scope of the journal. For example, I cannot submit the some particular material research work in IEEE because they're particular unless I have something like developing some new model, electrical model, or I integrate my lithium battery into the autonomous vehicles or anything. So there I have something like automated system, etc. You can try. So that's why we need appropriate things. So that's why you to do it appropriate journal. Choose the journal that fits into the scope and receive from the larger. So and also we have to see sometime in future if you can get the citations, etc. Okay. And who publishes more articles again. So again, it is very important whatever the way. So sometimes in some particular areas, who is going to read your community accordingly, you have to select that particular journal. I know there's some particular discipline, some top journals are there, so accordingly you can submit. I understand it is a little bit difficult to, if you go for top journal, which they'll see the quality. Still, there is a way, general way I'm telling you, still if it's not possible, you can try for low impact factor journal, etc. So these are title, abstract, and paper. This also I'm going to the relative amount of views to different sections of a paper. The good title is very important. Always based on title, fancy title people can read, and then the first always title based on, you know, so many papers they'll see title is good. Oh, please go through. Again afterwards the people see next step is abstract. Oh, with abstract they can tell all the stuff. They can get the overall idea. Then if they are very much interested or some specialized people, they'll go to paper more detailed line by line. You know. But not all the people line by, again the specialty people can do. This is a way. So they're getting visibility of your paper. There's a way once you publish, these are things. Again, title of the manuscript. So it's very important. Tip one is that attract the potential reader. So it is very important and grammatically correct and accurate, and this is the way title of the manuscript. And title should be informative, accurate, and concise. Again, so these are the good and bad title. I'm talking about something like some materials thing. Again, it applies to the engineering, mechanical, etc. So I don't. So these sometimes depending on the we don't give too lengthy title like that way. Depending on you, just to see the accordingly, or sometimes in title itself improve the performance by Wang et al. Something like title itself. People they write they put title followed by Wang et al. Means or Reddy et al. Like means the author's name is put, and that is not really. It's also like bad title. So don't put like author's names in the title itself. It is not allowed. And a few other examples you can see. For example, real data simulation control mechanical system and their uncertainties. So these are the in something like simulation, advanced modeling and simulation. This particular journal. Again, type of authorships. Again, if once you call it the first author, what called lead author is the primary responsibilities and most substantial in the sense that contribution is being done by, for example, suppose your PhD students are BTech or master students, you are the person, the first author, I think you will be responsible. Always it is to follow some ethics. Sometimes I know that it is very difficult to go through all line by line to our experiments. Usually when I used to work in Singapore, most of the times I used to go through things. I have a little bit time or to focus is make sure that whatever the student, I know that sometimes students they climb very high values. You have to see carefully really worth it or not. That's why I will check the results. Sometimes people do mistake in the mass. Sometimes we get high values. So that one I don't agree. Then again, I check the data, make sure that everything is okay. So what time does that reputation, credibility is very important. That's why sometimes is so try to do it in a proper way, ethical way. So that is very important. You will do. I know sometimes it's very 100%. We cannot like sometimes I know that my own example because some of the work. So sometimes people already we publish some paper, then sometimes people will not cite and their particular references. So they think that if you cite, so if they're submitting the paper in high impact journal, it may not accept, saying that oh, the already paper is submitted and no point. So sometimes people will do mistake. That is okay. So ethically, anyway, we don't want to tell that they are good. So that's why sometimes is the introduction. What are the previous literature people have done? So as a first author, I think people go through carefully. Now softwares are available accordingly. You have to cite the references. That is my opinion. So again, submitting author deals with the journal. Again, the who is means corresponding author is the boss, your mentor. So mainly he will take care of responsibility. Again, the address everything, all submitting, and then again, sorry, this corresponding means corresponding, and the last author is also like okay, supervisor of the research work, etc. You know, this will cycle vary depending on the if you are working with a different multidisciplinary, it may go to second author, third author. It like depends on how many people are contributing in a particular paper. So again, abstract, briefly state the problem and scope, indicate the methodology. Again, I talk and summarize the principal finding of some data and point out major conclusions and check the journal is very important. Sometimes it will we have to follow the general length and some journal that will okay restrict to this particular wording accordingly to restrict. That is my okay. Tip 2 is that write abstract accurately, make sure that accurately reflect the content of the manuscript, either review or original article. So anyway, you can see some particular, you can give some title or abstract or keywords. So automatically you'll see that you'll get some idea. So anyway, a lot of software, Scopus or Engineering Village or different type of these softwares are available. So again, it's very important to whom you are writing. So why should they read your article? So it's very important, and to make them to understand your work. So it again depends on which type of the and also what does it do, and discussion how the problem is being solved, and describes where your research is fits into a current system. And the schematics is very important. What are the problems have been addressed, background and literature reviews, and a new development and principle, and research. What is the purpose of research? And state 2 or 3 introductory paragraphs and present recent advances, motivation of conducting the study, and scientific issues has been they'll always this is a little bit tricky, so you have to be careful. So sometimes, so my suggestion is that you can do something recent or some reviews or so that made them to okay. So it's not really old research. Still, people are doing some advanced research like that way. It will make an impression. Still, I know some particular area. I know sometimes. Some world concept. Still, the world is also gold only. Still, sometimes breakthrough ideas. I think in my session you would read the world paper also will get some idea. So, so that's why it depends. Sometimes in some cases these are a little bit some trends I'm mentioning. So also some extraordinary some particular paper, which we can include that world advances also, because sometimes in some domains some old papers are hidden in somewhere. So nowadays because of the software, so previously they used to read all these something like hard bounded volume, sometimes difficult. Now a little bit what they call as internet, they can access or they can see all the papers very easily. So again, the material methods and experimental details. What are the materials used in the research? Methodology of conducting the experiment. Characterization of material by what type of, for example, materials, different techniques. And if you, what is the preparation, or if you're doing biological studies, the cell culture, etc., you have to report. And qualitative quantity analysis of, for example, proteins, and instrument details are, for example, if what type of computer you are going to use and what type of software. For example, people are using LabVIEW, for example, analysis of data like that way. Again, or AutoCAD, or depends on the area we have to use appropriate software. Give a sufficient external details and reproducibility. For example, references. Suppose, for example, in the experiment itself, you can tell that some already some few paper from your own group or your own work. You can mention that is also saying that previously, instead of writing too many details, you can tell more details of the work has been reported from the previous group like that way. Okay. When doing standard method, provide what are the details are needed. That is one thing. So for example, if you talk about the material synthesis and characterization, what type of the okay, what type, if you want to prepare some material, what type of methods are using accordingly, you try to explain. Or sometimes IEEE engineers, so they use something like sputtering unit or some thin film fabrication. For example, silicon nitride. For example, you can see you have something like osmium oxide 3 nanometer, silicon oxide is 1 nanometer. So this is like these are all the something like thin film. So there, I think we have to need which type of the technique. So most commonly, for example, as the research you're doing, you may buy some particular commercial sample. You can tell the commercial sample purchase from some company, etc. I can mention. So that's why that will solve your purpose. Or you are prepared by yourself. You can tell that this particular films has been prepared by the ALD or RF sputtering, etc. Or some mechanical engineering. So they're preparing some lightweight alloys. So they can talk. I use hard press or additive manufacturing, 3D printing, or spark plasma sintering, etc. So there is a way you can tell, and then you mention what type of experimental condition, which is the instrument, and what is the temperature, and how long you press. There are all things you can include. So these are all brief. So I don't want to tell too many story about this. Something like more details and the. Okay, so it applies to the engineering. For example, accordingly you have to use engineering, what type of software and what is the one I can do. And again, what type of the characterization tool you are going to use, and accordingly. And then, for example, software is very important. Sometimes how to treat, what for example, extract the data or analyze the data. You have to use appropriate software. For example, something like what they call LabVIEW or so different type like AutoCAD. So there are the different type of the software you're going to use accordingly. You can use, or for example, crystal builder or something like depending on which type of the something to creating the structures, etc. So again, if it is theoretical paper, you have to use you have to use appropriate equations and software, for example, appropriate software, etc. You have to use. So results is very important. Once you explain the data collected in statistical error and appropriate model, and only the relevant data is enough to justify the conclusions. It's very important. If equations, figure, table should be more visible and nice clarity. This is very important. Sometimes I know that sometimes like for example, figure captions they'll do, or y x and y axis. Sometimes they'll put very small font in this. For example, x and y axis they made to 12 because usually we are habituated 12 to 13 or 12 to 16 fonts or Roman or so my suggestion is nice to especially figure y axis x axis depending on the cortical cap x and y axis font. So nicely visible, maybe try to go for 28 to 36 so that once you put in print again they will compress it, so that way, so accordingly you have to prepare the figures. Again, color figures significantly enhance the clarity is very important. Again, it will vary depending on which system to system. So again, multimedia videos, recording, and some particular things is
Actually,
nice.
zero will be open in the evening, no?
Yeah. So video recording, etc. And with a separate supplementary, for example, sometimes I know that we are not able to include all thing in a particular things. You can include the supplementary files. Okay, what they call as supporting information or supplementary files like that way. I think it is almost like this type of the concept is almost same with respect to all type of domains including science and engineering. So I'm telling that depending, for example, this particular thing, we need something like fancy, good images, good quality images. You can give and appropriately you have to explain the legend, etc. So, for example, this type of particular graphs. What I am mentioning that is so this y-axis and x-axis should be properly visible. Saying that that's why I try to don't too small size font at the end. Once you compress it, this particular one final printing, your size is too small. Sometimes doing editorial process or general office, they will tell you okay, size is too small, or sometimes doing revision, they will tell you to improve the quality of the figure, etc. Again, in terms of the figures, again you can see that these are the one particular figure, so you can improve the x and y axis. People can correct size, etc. You to do. Again, I mentioned these are not my own. This is the literature data. Sometimes you have to use appropriate diagrams for that case. I think these one, for example, full phase shift, full bridge converter. So these just like some data I collected. So sorry. So data I collected. So accordingly, so it is nice as a researcher, a creative researcher. The same thing you can make it to color things or color diagrams, or sometimes you can do different way, or if, for example, this particular things you make it to different color like that way. So these are all like creative art in nowadays. I think only remember you to spend some time. So for that case, that's way we can improve the what they call as the legibility, view the graphs, etc. So this one only like sometimes people, your professor or mentor don't have any what they call as time since he's busy with the teaching some other assignment. As a researcher, it's your job to do it. As a mentor, make sure that whatever. Sometimes I know that you're doing students doing by experience, they will do mistakes, so that our responsibility carefully check that all the science everything is okay or not. So that's why this is a way a part of learning in the academic institutions, etc. So again, these are the different type of the electrical circuits. You can see this color resistor, constant phase element, or electrical engineer they use resistor, capacitor, inductor. So like that way, depending on the research, they can use different type of the equivalent electrical can do the figures like that way. So again, so sometimes we want to clearly explain what is the significance of this resistance or what makes them. Especially you discuss more details in the what they call resultant discussion. Oh, this particular resistance because of this one, either due to some problem, something like that way you can do. So why am doing this particular impedance spectroscopy very useful for electrical engineers also. They can see the thin films if it's good or not, or integrate circuits sometimes, or your contact is good or not. Sometimes it's good contact or good films. We will get something like beautiful shapes. If it is a lot of noisy, oh, something is happening with your system. That's why something like contact is not good, or there is this problem with the short circuit, etc. I can check by using these particular things. So again, discussions is very important always. So what is the uh, uh, propose and discussion, interpret the compare the results, briefly state the logical implication of results and discussion results obtained with the literature, and include the reference in appropriate place of time. Is very sometimes I know it is a little bit difficult sometimes if it is really new one, so it's very difficult to put it in the what example saying that I am getting these results when compared to the previous results. I'm able to get slightly improvement in the performance or efficiency like that we can do. I know some cases you can it is very difficult sir, unless you're doing new one, you don't have much to compare. So still you can tell that these are we don't have since the first time report, and then you can mention that not difficult to compare, or you can tell that probably this study is what they call as a fundamental studies, and this study is very useful to further studies, or for example later use your idea. I think some other ex people they can verify, or they can vary the model, or depending on that one you can do. So it is very important to discuss what has been contributed and what is the benefits of the study, and additionally what is done, and compare the data, statistics, etc. So it's very important to always mention the error bars. So for example, this is a mechanical property of some materials with respect to the hardness versus temperature. So you have to see depending on the alloys or whatever this may, you have to mention the error bars, okay, so that's very important. So for example, another thing is mention the error bars in terms of Young's modulus versus porosity, some particular system you can see with respect to the, so this is a way I'm mentioning. There's another example, for example, all solid state batteries there. We want to see this type of the graphs, we can tell the how the this and this is one another example, wavelet based power management in the hybrid electrical wave system. So again, I think there. So I think these are the electrical people they can do. So they can see the how the program, for example, high frequency load. These are all the things we can. So I'm telling depending on the which type of the, for example, electrical. So depending on the research and what is the research you're going to do accordingly, you to use appropriate schematic model or etc. These are the typical schematic power flow model for the electric motor cycle with ESS, and then during electrochemical storage system, etc. So again, once I think the paper is ready, and the next step is the while writing a reviews. Reviews is like always collecting what is the research is going to happen. Reviews advantage of research reviews is that so instead of writing individual paper, the important papers have been summarized instead of writing. So 30 pages you summarize briefly. That made them to as a researcher start the new people can see what is going on this one and what other people have been done. That will be very useful. That's why my suggestion is that reviews also you can read, so you'll get some idea before starting the research that makes you. So once you want to write a write reviews also different ways. I think nowadays anybody can write a review. Like olden times, during my time, I'm talking about more than 15, 16 years back. The time once you want to write a review, you have to spend more almost in a particular area 3 to 4 years or 5 years. So at 7 years, make sure that you are able to understand the things, and then it will be easier. You feel for what is the review you are writing. Sometimes nowadays people with young research are doing bachelor's also we can do. One way is good, and the only thing is sometimes experimental they'll not feel for it. Still it is good for them to learn what is going on happening, and that made them to easier for them to, especially future admissions, etc. So again for them sometimes you may not judge 100% really, will not feel for what is going. Still it is nice to report something. It's okay. So again, we need to make a nice figures. For example, always best way that you merge the figures from literature. For example, I know some different papers, so try to merge in a with a different paper. For example, this one particular images in the review, so you can see different type of papers you can merge. That is the one way. So, and also there's another example, something like schematic diagrams, etc. This is also another example I collected from literature. So this also from the perovskite. So there, so this one particular review you can see they have summarized what is going to happening. The real research has been started by 2099 and some small improvement breakthrough, and 2013, 14, 15, so 15, etc. and 16, and what is the future. So this type of what they call as graphs is really useful, so that sometimes you will get. So here they've been summarized. You can see important. Not all the people cannot do one. The breakthrough papers, like breakthrough things, have been summarized like this way. And again, for example, if you talk about the metallurgist, something like gel casting, spray there, I think we have to use this like gelating agent. This is a way of creativity always. Okay, you can put our later if you are engineers. I think you are nowadays you are smarter if you know the what they call PowerPoint, and then like you know the paint system or some other softwares you can do. You can develop the very beautiful nice images. So this is also one example with related to the one particular things. Again, I think this particular title maybe this one opportunity challenges. Again, the same title you can give different way. Again, sometimes if title is wrong, so, reviewer or a referee they may suggest you modify accordingly. You can see this one particular example. Always the literature, and these are the way I'm telling beautiful figures. We can merge it and we can put it in a schematic way. Also, there's also some the same particular the MgCO2 with the different methods of preparation. Again, we can see the shapes, everything. Only I collected one particular. We collected one particular image with one particular paper like that way. Or here, this something like some simulation studies, etc. So I think I'm mentioning that we have to compare this particular depending on 2 electrode, 3 electrode. You have to need appropriate diagrams, etc. So I think these are the way tricks I'm telling. So how to improve the visibility, and sometimes you can see the literature data, and then you can do see the experimental and summarized data, etc. Okay, so these are all the way. So some supercapacitor summarizing is the way we were done. So this is a way. I think it will vary depending. I'm telling these are all art, and this some particular example. It will vary depending on which type of system. In summary is necessary most of the paper. On long paper, summary should be brief and concise. Make sure that okay important points to, and again the some cases some case summary will not be there, or summary in conclusion, or some paper they may use conclusion. They've been solved. Repeat the discussions, especially relevant thing and conclusion should be evidence and presented. And the same thing what I told you in the something like some points are repeating with respect to the scientific methods. So references should be numerical order appearance, follow journal style, and use some different type of software nowadays. I know that olden times all people were typing or were writing in a manual. So now if you have too many reviews or writing or paper, I think my suggestion is that I think it is nice to buy something like software. I think or some manually. I think this may be free if I remember. So you have to use accordingly. Or sometimes biological people they have some different type of the software, etc. So I'm telling that follow the general style accordingly. You can see sometimes initial will come first, and name like that way you can interchange, etc. So I think these are the books. We can write the cite the references and few other examples. For example, so these like this particular thing. So again, if you want to get more details, again I'm telling that you name a lot of YouTube, so many things are available. Again, you can this one particular example is the George Whiteside. You can click the YouTube in a Google what they call George Whiteside talk on how to write a paper. So then automatically it will tell. Although it is a material science way, still I think this way with motivate is very useful for you people. And improve the writing. Anyway, you can go through a lot of people are there. So I'm not telling not only depending on different type of domains we can get. Anyway, due to the COVID, a lot too many YouTubes are also getting, I think that will be good for you people. Okay, so these are a few examples. Again, I think so remember, I think these are very important. So these are people want to represent something like, so this is what that white side. Still life, it will vary depending on the different type of the journals. So now I think another so now is I've taken almost 1:30. So I'll finish within maybe another 10 minutes, like just to I think how to review process. So okay, so that then another maybe another 10 minutes to take a question and answer. That will maybe I'll leave early by 10 minutes. Okay. Also I know that it's 2 hours sometimes. All our what they call as time. So within 45 minutes or 1 hour is best time to listen. Still, since they give me 2 hours, it's nice for me to talk slowly. Just we can. Okay. So now I think this is called part 1A. Like part third is also will be there next presentation. That is called as a project proposal submission. So tips for writing a paper. Again, example once is ready, you have to anyway you spend a lot of expense. A lot of thing again. Another way also you have to little bit more time just to prepare a nice cover letter. Mention the editor name, title, and then name of the authors and highlight the novelty. Briefly, right? Don't need to write. Okay, that also depending on journal. And so in some most of the journal they ask you to suggest 3 just you can do. Sometimes they may select or sometimes they may not select. Also, it is always up to them. Again, they prepare nice graphical abstract and highlight that. That's also very important. Upload the document according to general requirement, and finally we'll get a reference number. So sometimes they may ask you some missing file. Okay, tell okay, their missing file is there, and try to submit. They will ask you, and you can do it. That is okay. And highlight the general requirement. If too long, editorial office will ask you to, for example, highlights. They will ask you to reduce. So that is also you have to follow. These are some few examples. So review process. General office nowadays compared to olden times, every the online submission sometimes very fast at previous, like almost 25, 30 years people have to write a paper and submit it to by post. It will take more than I think the post keep it close for 1 month, 2 months like that way. So that's why sometimes so at the time they're publishing 1 or 2 papers throughout their career is a very is a big issue. Now since because of this particular online system, I think it will be easier for us to especially we can save the timings. That is the advantage. And also general process will quickly go through missing documents. If any error, they may ask you to resubmit. Later, depending on the work, general editor will go through your paper depending on the impact factor. Sometimes high impact factor is there are a lot of screening because so many papers are submitting. So they have to select accordingly which are the journals, etc. Some journal we can expect more rejection due to the more publication submissions and novelty of the work. And sometimes don't worry. So I know that all people cannot publish in Science or Nature magazine or very high, what they call as high impact. Still, this is the way I'm mentioning. Once initial screening is done, the paper will go through under review, and it may take 15 days to 2 months depending on the example how the editor or reviewer is free or not. Or some journal they're very fastly they can send the comment. I know some journals is a bit slow time because there are a lot of editor has a lot of other assignments. Sometimes it may do or sometimes they're waiting for the referee's comment. So some cases we may see 3 to 4 months. Also some examples also there. I also my own experience. I got from 5 months time also that is normal. So best way is that just to remind them. And sometimes people do always if you delay just to remind them. Again, general editor will decide whether paper is acceptable to the minor or major. So based on the one, you can do it. Answers correct carefully. I know that sometimes highlight what are things happening. If you're not able to do suggested experiment, please possible suggestions saying that we're going to further studies.
कधीपर्यंत करायच्यात?
Yeah, further studies are not there, and also in some cases, second and third revisions are needed. Yeah, so, second and third revisions, and some examples may go. We have to take into consideration. So again, acceptance of the revised paper. General once decided to accept. So carefully check all the errors submitted by all author. If any error, make sure that corresponding author must submit within 2 days. So sometimes we don't do, they can do whatever. So that's why my suggestion is that And during proof correction also, you see carefully. Some mistakes are there, you can correct, so you need not to worry about. So sometimes, especially figures, you did that one, just you can upload it. That nobody will tell that no, because unless there is too much of modification still. So my suggestion is that you can modify during proof also. Also, you need to more time. Yeah, sometimes you know that you're busy, or sometimes they'll ask you 48 hours. I know some cases, I know you don't have much time, or you have to check carefully. It is responsibility thing that you can tell that, okay, say I need more time, or I can do another one day, like that way you can adjust. Again, another is proofread will go to online if not possible. Once it's submitted, again online not possible to correct. Or sometimes while submitting, do too many mistakes, you can tell that, okay, this is wrong, and some comments it will be there, what they call erratum, then you can tell, okay, replace that when those are all things will come. So that sometimes there's normal, some people will do mistakes, it will get. That's why it is nice for us, especially title, for all things to carefully check that one, don't do mistake. That is my opinion. Okay, and I'm asking about impact factor. Okay, there's also, it depends on where you are coming from and which institution. So many things are there. I don't want to tell too many stories. So again, impact really is important. That makes you difference. There is question mark. And again, it vary depending on which country, which origin, and some people they will not bother. Oh, I don't care about impact factor. Invest with impact factor. Good or original paper has been read by author. It is very important. And some, I know some low impact journal paper also, they've been won the Nobel Prize. Now I don't think that all say published paper in Nature or Science magazine they won Nobel Prize are nicely cited. So they're not a correct one. So these are the points I'm mentioning. So what I'm mentioning as a researcher, so as a student, so what are the way, at least you just to communicate, at least that is in this process you're learning how to write a paper. So, there is a lot of options like they call open access. I know some cases you have to pay a little bit more, but still they'll go through referring, or you can try to submit something lower impact. But that way, at least whatever the students have been done, your effort is going to be okay. So there's one example I'm telling that is called a material research bulletin. So this is almost like now it is like 40 years. The olden time when the prestige almost olden time, always all the people. Material research bulletin is very, now these are top journal in materials. Now I think this has been beat by some other journals. It's not now, it's not no more top. So nowadays 20, 30, 40 some high impact journal. Still all Nobel, for example, Nobel Prize winning work, for example, material research bulletin. I think one of the Professor John Goodenough is a person sitting here is a 99 year, one of the oldest Nobel laureate. I think he published his paper in the, for example, Journal of Material Research Bulletin. You can see 1980. So what I'm mentioning at the time, I think it's also editorial, but still at the time is there. So you can see almost very small paper and a small thing. See almost like 3 to 4 lines. Then okay, when idea is that is good ideas. Only you can put what is important. They don't care about language. So good ideas are there. So everything it will go in science. There's no boundary with language. Only they see the what is going to happen. So anyway, this one I think I'm also one of the editorial board member for this particular journal. So another example is the Nobel Prize in 2018 physics. So in the optical teasers. So again, some people from I think she also I think one from some Canada, if I remember last one. So what I'm saying, they published in the optical communications. So in 1985, I think they won the Nobel Prize in 2018. So again, at the time, I think these are recent impact factor. Golden time during the time, maybe low or whatever. So what I'm telling that, so Nobel Prize also got with Nobel with less impact. Sometimes I know sometimes you may publish one impact factor less than 0.5 also. Some breakthrough ideas or some novel things people go through, and then you may get Nobel Prize also. That's why I'm mentioning. Okay, so these are the things I want to tell. So I want to tell you my own example. For example, some chemical reviews have been submitted long back. I'm talking about 2010. At the time, I didn't bother about much. Golden at the time is I think around 3.5 or 4. So first we submitted work into something like the invited submission 2010 as a General of Material Chemistry A as a Royal Society journal. Almost we spend especially me, I spend more than 1 to 2 years with a lot of hard work and dedication. And afterwards, editorial reviews, they ask us to edit referees condense and reduce the length of your paper. Finally, I know that I've spent a lot of time and energy. I don't do I don't want to do reduce the things I taken withdrawn means I would like to withdraw my manuscript. Finally, same work, same thing I submitted to chemical review. I think this is almost maybe 30 times. Now it is a 50 the impact factor. So what I'm telling that again it took almost 3 to 4 years. Anyway, this journal is very highly specialized, and then almost it took me almost like a lot of time and dedication, not so easy. So at the time is also we don't have less pressure. That's like that way. There are all things we learn by what not the promotion, just by interest, and then by all the experience we've been contributed. And this is my own experience. I'm telling that again. It took 20 publish, and finally we published in the around 20 almost 3 years it took for me to publish one particular at least means 2010 almost like at the end 3.5 years to submit. And again, you know that all hard work, whatever we done is like this is like a Bible in the whole history of the community. Still, this paper is people have been well cited. Almost, I think this whole data. I think now is around 2,600 citations, and at that time is one of the hot publications, etc. Anyway, sometimes you may citation after a year it may reduce. Also, still the world is a good reviews have been well cited. So again, these are the different type of mechanism, etc. So now I think I'm going to conclude saying that this first part of the presentation I've been covered the importance of the, for example, scientific method or something like how to write a published paper and review process, etc. So what I'm mentioning as a researcher or anything, I think any paper or anything you can do depending on the what is the research, and it's like I think once you get a result, I think nowadays all the internet is there. I think all people can know previous wallpaper. I think you can do that. Is not a like modification of the layout. I think we can do that. Is not a main issue. So and thank you very much. Maybe so next what they call a part 2. This one I'm going to discuss in the coming. I think another maybe 25th or something. Another day I'm going to discuss. Okay. So now. So before concluding things, I think I have another. I think I've taken almost like 1 hour 40 minutes. I think my session chair also, I think introduced me for almost some 5 to 10 minutes. So I think we have another 10 to 15 minutes. So that maybe if you have any question and answer, happy to answer. So I don't know really. So that is my personal opinion, and then and happy to see. So what am I mentioning that the personal things, it is nice for us to this type of workshops are very good for us to learn something different back. For example, in this conference or workshop, a lot of people from engineering background or business backgrounds, a lot of people can talk at some industries. So that way we can what they call enlighten the things. So my suggestion is that I know some since background is different, you may not catch up all the points. Still, it is nice to listen some important point that will be very useful. At least we can call a take home message. So that is my things. And also before ending my presentation, I would like to thank Professor Shishikala Madam, head of the department, for conducting this session. Also AACT for their motivating. I think this type of things are really useful. So not only this, I think this is a way I think that especially for if you talk about AACT's program with especially some things related to the fundamental are applied with a different specialized, for example, IoT related to the computer things or something different programs that may be very useful for example, electric vehicle workshops or advanced material workshops or mechanical ceramic composite workshops or, for example, power transportation. In the different type of workshops are going to help. So that is why my suggestion is please go through this portal, and then interested researchers please go through that particular things. I think that will be good for you people to enlighten the knowledge. Okay, and then so that is my suggestion. And also another take home message is that I know that accessing the equipment is a little bit difficult. So my suggestion is that whatever the locally people have some facilities, just collaborate. And right, anyway, I'm going to talk about the next presentation, like in grant and what is the how to just improve, for example, getting the instrument that way accessing. So that's my personal opinion. So that way you can collaborate within your college, or so especially Bangalore, we have so many colleges at the time. Sometimes all the people they don't have much facility. Still, you can access depending on the available facility within the institutions or some external university, etc. Anyway, thank you very much, and yeah, so good evening to all. Thank you. Thank you, madam. So
Thank you, sir, for your wonderful speech and the information what you have shared regarding the research and innovation. So how to work towards the research with respect to the ideology of material synthesis and characterization technique. Thank you so much, sir.
okay, thank you. Thank you.
Thank you, sir.
So whatever the last slides are visible, I'm not sure because I don't know. Sometimes
It was
visible.
visible. Sir. It was visible.
Okay, perfectly fine. Thank you, sir. Thank you, Professor Manjanath.
Thank you, sir. Thank you, sir.
Thank you, sir. Thank you, sir. Thank you.